Well, here we go, back at it again with our Geometry B first video for Chapter 9. Alright, so we've got 9.1, Day 1. We're going to do 2 days on 9.1. We're going to talk about simplifying radicals. So this is a review from Algebra 1, so hopefully it seems a little bit familiar. First we want to list the perfect squares through 15. Now perfect square, I'll go ahead and start with 1. 1, if you square it, you get 1. So that 1 is a perfect square. 2 squared is 4. So 4 is a perfect square. 3 squared is 9. So 9 is a perfect square. 4 squared is 16. That makes 16 a perfect square. So basically, if you square a number, the result is a perfect square. Another way to look at it is all of your perfect squares, you can take the square root of them. So we have the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. Alright, so if we continue our list, 5 squared is 25, 6 squared is 36, 7 squared is 49. We're going all the way through 15. So go ahead and pause the video and just go ahead and write them in and then check and see if you got them all right. Okay, so there's all of our perfect squares through 15. We ended with 15 squared, which is 225. So if you have to simplify a radical, the first thing you want to ask yourself is, can we actually take the square root of 144? Is 144 a perfect square number? And because it is, that means that it has a square root, and the square root of 144 is 12. Now when we're simplifying 108, if you check to see if 108 is a perfect square number, you can't take the square root of it evenly. So what you want to do is you want to think about all of your perfect square numbers and see if any of those fit into 108. So for example, perfect square numbers, I'm just going to list them again. 1, 4, 9, 16, 25, 36, 49, and the list goes on. We can continue this if we need bigger numbers. So what we're looking for is the biggest perfect square number that fits into 108. Basically, we're going to take 108 and divide it into 2 square roots that multiply and give you 108. So 108, start dividing by these till you get the biggest one, and you're going to see that 36 is the biggest perfect square that fits into 108, and it fits in 3 times. So the reason why we wanted this square root of 36 is so that we could actually take the square root of 36 and say that that equals a 6, and then the square root of 3 stays the same. And there's our reduced radical. Alright, this is the last slide of our intro video. Again, when you're reducing radicals, see if it's a perfect square number. So our example 1, square root of 4, well that's a perfect square number, so that equals 2. Square root of 16, that's another perfect square number, so the square root of 16 is 4. Now the square root of 18 is not a perfect square number, so we are going to work on reducing this. We're trying to think of a perfect square number that fits into 18. So does 4 fit in? Does 9 fit in? And you would say, yeah, 9 fits in twice. Alright, so how do we know if we found the biggest number that fits into 18? Here's a nice little trick. If you look at the other number, this is a 2. Do any perfect square numbers fit into 2? And I know that 1 is a perfect square number, but it doesn't help us with reducing, so we just kind of glaze over it and move on to 4. Does 4 fit into 2? Nope, it's too big, so that means that we did find the correct perfect square of 9. So the square root of 9 is 3, and the square root of 2 stays, so you have 3 square roots of 2. I'll go over that trick again to see if we found the biggest number. It's actually going to happen in this next one. So example 4, the square root of 32. Think of what perfect square numbers fit in, because it's not a perfect square itself. You might say, oh, 4 fits in 8 times, because 4 times 8 is 32. So what you want to look at is the second number. Do any perfect square numbers fit into 8? And go through the list, 4, 9, 16, and you say, oh yeah, well 4 fits into 8. What that means is that 4 was not the biggest number that fits into 32. So you can go ahead and start dividing by bigger numbers. So 4, 9, 16, and then you say, oh yeah, 16 fits in. 16 fits into 32 twice, and then the square root of 16 is 4, and the square root of 2 stays. So in your reduced radical answer, the number underneath the radical, or the square root symbol, will never be able to have a perfect square fit into it. That's when you know that you have this in the most reduced form. Alright, example 5, square root of 27. So go through the list. 4, 9, 16, and you say, oh, 9. 9 fits in 3 times, so the square root of 9 times the square root of 3. Here's the check. Look at the second number. Do any perfect squares fit into 3? Well, 4 is the first one we would check, and that's too big, so we can go ahead and simplify. The square root of 9 is 3, and the square root of 3 stays. So we have 3 square roots of 3. Alright, so square root of 256. Again, first just try and see if that is a perfect square by itself. And if you take the square root of 256, you would right away get an answer of 16. So 256 is also a perfect square number. We just didn't have it on our list because we only went up to 15. So that's how you reduce radicals. Hopefully that seems a little bit familiar from algebra last year.